Hello there, this is General Mahendra Popat. We are discussing Geotechnical Engineering, Soil Consistency. This is video part 3. In previous two videos, we have discussed Atterberg's limits or consistency limits as well as experiments or tests for plastic limits as well as liquid limits. Let us go further in this topic. Sensitivity of soil. It is observed that cohesive soils, upon remodeling, lose a part of their strength. The loss in strength upon remodeling is attributed partly to the breaking down of the original soil structure and partly to the disturbance caused to water molecules in adsorbed layer of soil. Sensitivity is a measure of the loss in the strength of soils as a result of remolding. It is defined as the ratio of the unconfined compressive strength of undisturbed soil to the unconfined compressive strength of remolded or disturbed soil at the same water content. Sensitivity is denoted by capital S and in suffix T. Equation of sensitivity is equal to Qu in bracket undisturbed upon Qu disturbed. Qu is nothing but unconfined compressive strength of the undisturbed soil sample and Qu disturbed is unconfined compressive strength of the disturbed or remolded sample. Do remember that both value should be at same water content. Depending upon sensitivities of the soil, soils can be divided or classified as if sensitivity is less than 1, the soil type will be insensitive. If the range is in between 1 to 2, it is little sensitive. If it is in between 2 to 4, it is moderately sensitive. If in between 4 to 8, it is sensitive. If 8 to 16 is the range, then it is extra sensitive. And if sensitivity of any soil is greater than 16, it is a quick. Now, for most clays, sensitivity lies between 2 to 4. If sensitivity value of clay lies between 4 to 8, it is considered to be sensitive. In case of sensitive clays, remodeling causes a large reduction in strength. Quick clays are unstable. Quick clays turn into slurry when remolded because of the higher sensitivity. Now let us go to thixotropy. What is thixotropy? The loss of strength of a soil due to remolding is partly due to change in the soil structure and partly due to disturbance caused to water molecules in the adsorbed layer, as we have talked previously. Some of these changes are reversible. If a remolded soil is allowed to stand without loss of water, it may gain some of its strength which is lost earlier. This phenomena is strength loss, strength gain phenomena, and it is called thixotropy. The gain in strength is due to rehabilitation of the molecular structure of the soil. Thixotropy of soils is of great practical importance in case of pile driving. When a pile is driven into ground, the loss of strength occurs due to disturbance caused. Thixotropy indicates how much shear strength will be regained after the pile has been driven and left in place for some time. Hence, the frictional resistance of a driven pile in a clay immediately upon installation will be considerably smaller than its value after a month or so. So, thixotropy plays an important role there. Let us move forward to numericals. Problem 1. A soil sample has a liquid limit of 30%, plastic limit of 17%, and flow index of 13%. We are given these three values as well as natural water content of soil is 19%. Now determine plasticity index, liquidity index, consistency index, and toughness index. As our practice, we will write given data first. So in given data, WL is equal to 30%, WP plastic limit is equal to 17%, IF which is flow index is equal to 13%, and natural water content is equal to 19%. For first item plasticity index, we need IP is equal to WL minus WP. We are having WL value 30 and WP value 17. So IP plasticity index will be 13%. We know the liquidity index formula W minus WP upon IP into 100. So natural water content as well as plastic limit and plasticity index, all three we have the values. So putting all the values in this equation, we get IL liquidity index as 15.38%. Consistency index item 3, we already have the formula IC is equal to WL minus W upon IF into 100. So putting all the values, we got consistency index as 84.61%. And last, toughness index IT is equal to IP by IF. And as IP and IF both are same, plasticity index and flow index both are same, so we will get toughness index 1. I suggest you to practice these types of problems more and more. Let us go to next problem. Problem 2. A fine-grained soil has liquid limit of 60%, plastic limit of 30%, and natural water content of 20%. Find plasticity index and consistency index as well as classify the soil and comment on the type of soil. As per the practice, we will write given data first. WL is equal to 60%, WP plastic limit is equal to 30%, and natural water content W is equal to 20%. We want first thing plasticity index. We know plasticity index formula very well. WL minus WP is equal to IP or plasticity index. Putting WL and WP value as 60 and 30 as per given data. So IP is coming, plasticity index is coming 30%, which is greater than 17%, which is greater than 17%. You must remember the plasticity index table for that. And according to that, if the value is greater than 17%, the given soil should be noted as highly plastic soil. Item 2, consistency index. We know consistency index formula as well, WL minus W upon IP into 100. So we are having WL value as 60, natural water content as 20, and IP as 30. Putting all the values, I am getting IC as 1.33. Now when consistency index is greater than 1 means 1.33, we know it from the table of consistency index. Whenever IC is greater than 1, the IL will be negative as well as consistency of that soil will be noted as semi-solid or solid state. You should practice this type of sums more. Let us go forward. Problem 3. The consistency limits of clay are liquid limit is equal to 52%, plastic limit 30%, shrinkage limit 18%. If a specimen shrinks from a volume of 39.5 centimeter cube at liquid limit to a volume of 24.2 centimeter cube at shrinkage limit. Do note that specimen is shrinking from some volume at liquid limit to some volume at shrinkage limit. This is the most important statement in the problem. Calculate true specific gravity and shrinkage ratio. So in first step we should calculate at liquid limit. volume 1 was 39.5 centimeter cube, and at that time true specific gravity capital G should be gamma s by gamma w or rho s by rho w. And at shrinkage limit, when the volume was lesser, shrinked, V2 is equal to 24.2 centimeter cube. Then shrinkage ratio will be SR is equal to gamma D by gamma W or rho D by rho W. Let us compare difference of mass of water in the first case as well as in the second case. So for comparing difference between the mass of water, we should compare in one side of equal to the volume difference and on other side same the volume difference. Let us check how in one side right hand side of equal to is volumes at case 1 and at case 2. At case 1 the liquid limit was 52 percentage, so I'll write 0.52 into MD. MD is mass of dry soil minus the gap at the case 2. At case 2 when volume shrinked, the shrinkage limit was 18 percentage, so I'll write 0.18 into MD mass of dry soil, and these gap 0.34 MD will give me the MD. MD is mass of dry soil is equal to 45 grams. Now I will use MD further. Now I'll calculate volume of solid. Vs is equal to 24.2 minus, I am calculating volume of solids at case 2. 24.2 minus 0.18 into MD. Why 0.18? Because at case 2 shrinkage limit was 18 percentage. Putting all the values and MD value, I am getting volume of solids at case 2 as Vs is equal to 16.1 centimeter cube. We know density of water very well. Rho W is equal to 1 gram per centimeter cube. Now let us find out finally true specific gravity and shrinkage ratio. For true specific gravity, the formula as we have discussed earlier, we can use gamma s by gamma w or rho s by rho w. Here I am using rho s by rho w because I have volume in centimeter cube and mass in grams. So I will use gram per centimeter cube unit and rho. So density of solids upon density of water. For rho s, I can put it MD by Vs. MD is mass of solids upon volume of solids by rho W. We know rho W value. We know now MD value as well as Vs value. So I can get capital G true specific gravity as 2.8. For shrinkage ratio, we already have discussed the formula rho D by rho W. For rho D, I can put MD by V2 because shrinkage ratio, I'll put the volume, shrink the volume. So MD by V2. I have MD value as 45, V2 volume at case 2 after shrinkage, after shrinking it is 24.2 and rho W is 1. So shrinkage ratio will be 1.86. So here I conclude the soil consistency topic. Thank you.